Okay, so this is a problem called the Pacific Atlantic water flow. So you're given an n by n grid um, that is bordered by the Pacific Ocean to the top left, and then the bottom right is the Atlantic Ocean. And pretty much the question asks you to um, return a 2D list of coordinates, 2D coordinates, RI, CI, which denotes that water can flow from cell Ri to Ci. So in this example, 0, 4, this can just flow into the Pacific Ocean and the Atlantic Ocean, right? Um, so we're trying to find cells that can flow into both oceans, right? And water can only flow, get to an ocean if it's like, if that number is greater or equal to the next cell, I think. So the island is partitioned into a grid of square cells. You're given an n by n grid where this height, so height RC, represents the height above the sea level. So neighboring cell's height is less than or equal to the current cell's height. So let's see, 5. Okay, so 4. So 5 can flow into 4. Well, okay, these cells on the borders, right? They can kind of like start flowing from the corners, right? So 5 can flow into 4, and 4 can flow into 4 here. Here 5 can flow into 6, which can flow into 7, which can flow into 5. That's not quite right. The cell's height is less than or equal to the current cell's height. So adjacent to an ocean, into the ocean. Yeah, so suppose you have rain falling onto these cells. How can it flow into another cell? It can flow north, south, east, and west. So we have up, down, left, and right. And yeah, so when rain falls onto this island here, we want to see. So these ones are just trapped here because they can't flow into both oceans, right? So these ones on the top left here they can flow into the Pacific Ocean, but not the Atlantic Ocean. But from 5 here is the middle. It can flow into 3, and then it can flow into 1, and then that's the Atlantic Ocean. 5 can also flow into 3 here, and then 2 here, and then into Pacific Ocean. That's why the cell is the orange color, because it's one of the answers, right? So 0, 1, 2, 0, 1, 2. So 2, 2 is an answer. Yep. And then 3, 0, 0, 1, 2, 3. 3, 0 can flow into both oceans via this route, 6 to 5 to the ocean, or just 6 to the ocean. Or it can go 6 to 5 to the Atlantic Ocean. So that's how it works. Let's see another example. 4, 0, 0, 1, 2, 3, 4. And this is 4, 0, which can flow into both. We'll try this one, which is 1, 3. So 1, 3 can flow from here into this cell, into the Atlantic Ocean, or it can flow from this to the Pacific Ocean. So you can kind of see the geography of how this works. The numbers inside the grid are indicating the heights of each cell, and pretty much it works how it does in real life, where if the next, like the adjacent cell is lower than that, then water can flow down, right? And we want to find basically all the cells that can reach both Pacific and Atlantic Oceans. Okay, so for that we're going to utilize BFS for this. I guess you can also do it with DFS, but we'll do BFS today. So the way we're going to do this is we're going to have the main function, right? So we're going to have a helper function, which is the BFS function, and the main function is going to go, it's going to go backwards. So it's going to start at all the cells that are touching the Pacific Ocean, and it's going to perform BFS on that, and then it'll start from all the Atlantic Ocean borders, and then it'll perform BFS on that. And at the end, we'll have two lists or two arrays of we'll have two arrays of pretty much all the cells that can reach the Pacific Ocean and all the cells that can reach the Atlantic Ocean, and we just find the intersection of that to find all the cells that can reach both, right? So first of all, I'm just going to initialize like what we need. Typically, we always need something like the answer itself, which is this. That's just the answer. And then we need an M and then an N, which is going to be the heights, right? So that's going to be, this is going to be the size of the input array, which is a 2D array. So the M height is just going to be equal to the column-wise length of the array. The N is going to be equal to the number, the length of each row, right? And so now we'll initialize a 2D array of we'll initialize a whole 2D array to replicate this heights, and then instead of integers, we'll change it to Boolean values to indicate if it's reachable to the Pacific or not, right? And then we'll have another 2D array that's going to say if it's reachable to the Atlantic, right? So let's just do that. Pacific, we'll call it Pacific reachable. And this is going to be M by N. And we're just going to duplicate that for the Atlantic reachable. So in the end, we'll have like 2 copies of the M by N grid, and each value of the array, the 2D array, is going to tell us if it's reachable to the Pacific. Right, so in the end, so we do our BFS here. This is the meat of our algorithm. We do our BFS to populate these 2 arrays, and at the end, we just loop over each cell, right? Plus, so that's going to be our outer loop to get each row, and then for each column, which is going to be equal to this. So if this cell, so this is just a loop, 2D loop with to traverse the whole grid, right? And for each grid, we're going to check if it's existing in both of these, and if they are, we just add them to our answer solution, which is a list of lists. So so we actually need to initialize the list here. So answer equals new, and we'll just do it as an array list here. Okay, so if it's reachable by the Pacific, R and C, and it's reachable by the Atlantic, then we'll create, we'll add pretty much add the lists, which is a set of, like a set of point X and Y. We'll call it satisfying cell. Add the R, and we'll add the C. And then we just add that to their answer, which is ants here. And at the end, we just return the answer. So that's the basic structure of how we're going to do this. So this is just the setup, and then we'll do the BFS, which is the meat of the algorithm. So I'll just recap what we did here. We created a new a list of lists here for the answer. We created this m integer for the first length of the array, and then n as the second array, and then we initialized it here, and then we initialized two different 2D Boolean arrays, one for the Pacific reachable and one for the Atlantic reachable, and they're both going to be m by n length, right? So now we can start the BFS, right? So when do we do Pacific reachable? That occurs when the row is either 0 or the column is equal to 0. So we can just do that here. So actually for this, we need to loop through each cell here and check if the column is 0 or the row is 0. So that's this vertical here and this horizontal here. And if that's the case, then we run our BFS. All right. So first of all, we need to loop through everything, which we can just copy from here. We are just traversing through every cell. And if the row equals to 0 or the column equals to 0, all right, then we'll just do the Pacific traversal, right? And the other case is when the row and column is equal to the length of the array, right? So if the row is equal to m minus 1 or the column is equal to n minus 1, because so this is 1, 2, 3, 4, 5. 5 minus 1 is 4. So if it's equal to 4, if the row is equal to 4 or the column is equal to 4, then we'll do our BFS on the Atlantic reachable array, right? So Atlantic BFS. So now we're ready to implement our BFS function. So since our BFS is going like north, south, and east and west, we can define like a helper 2D array here. We'll call it directions. Equals new integer. And this is going to contain different directions, up, down, left, and right. So this is going to be 0 and 1, 0 and negative 1, 1 and 0, 0, negative 1 and 0. So this 2D array is just going to help us generate all the possible neighboring or the adjacent cells so that we can add those to the queue once we do our BFS, right? Okay. So now we can implement our BFS function. So our BFS function is going to act on either one of these two, right? So what we can do here is we can call our BFS here. So buff public boolean BFS, and we'll have boolean. So we'll pass in either one of these. So it's going to be our reachable, and then we'll pass in the heights because we always need the heights. That's the input array, and we're gonna do the starting row and the starting column. So now we can put it in our queue. So we can just define a queue here of integers. which is it's going to be a 2-value array here for the x and y. And we'll just do linked list here. So at the start of the BFS, we're going to need to add the queues. Like we're going to add the starting stuff into the queue. So I guess we can just actually pass the queue in, right? So queue here. So when we go to call our BFS, we're gonna have a queue for the Pacific. Yeah, so we're gonna have a queue for the Pacific, and we're gonna have a queue for the Atlantic. So when we call the BFS, and we don't want to do repeated work, so we should always check if it's reachable already. So for every, like, one BFS can make something reachable already, so we don't need to go down that path anymore. So technically we can just do BFS, and then we can pass in the Pacific queue. We can pass in the Pacific reachable, the heights, the row, and the column. And again, we'll only do that if it's not reachable yet. So the reason we're checking this is that another instance of a BFS could already mark this current cell as reachable or not. So we don't need to perform BFS twice, technically. We can just put that here as well and just mirror it for the Atlantic queue. This one will be Atlantic reachable. Okay. So that looks okay. Let's implement the BFS. So how usually BFS works is while queue is not empty, we're gonna poll it, right? So and we're gonna make that reachable. So we're gonna poll the first coordinate, and we're gonna set that coordinate as reachable, right? So polled 0 is gonna give you the row, and polled 1 is gonna give you the column, and we're just gonna set that equal to true. Every time we poll a value, we're gonna set it to true because we already visited, right? So and we're only gonna allow like legal values or values that pass our condition to go back into the queue. So with that assumption in mind, we know that every polled value from the queue is reachable to that ocean, either the Pacific or the Atlantic. So how do we traverse the neighbors? So we just iterate over our direction array. And we generate our neighbor coordinates, which is polled 0 plus direction 0, polled 1 plus direction 1. So here, where Direction 0 and direction 1 are going to be these values here, which are just offsetting the current coordinate by up, down, left, or right for each direction here, right? And we're just using pole 0 and pole 1 again. So the R is going to be equal to the neighbor chords 0. And the column is going to be equal to the neighbor chords 1. And now we just check our bounds, right? If R is less than 0 or the C is less than 0, that's out of bounds. So if R is greater or equal to M or C is greater or equal to N, then we continue, right? Because it's out of bounds and that's an illegal cell technically, so we don't add it back into the queue. If it's already reachable, we can also disqualify that because we already performed BFS on that. And if the heights at this pulled value, let me see here, this one's like that. So if this value is greater than the heights at our RC, then we have to continue, right? So technically we're working backwards here. So we BFS on all these values at the start, right? So if this value is larger, the value that we pulled is larger than our neighbor, only at that time will we add our neighbor back into the queue. It's the opposite of going forward. So if we're going forward, 5 is greater than 3, so it can flow down here, and 3 is greater than 2, so it can flow in the ocean. But backwards, it would be 2 is smaller or equal to 3, so it can flow back up, and 3 is smaller or greater than 5, so it can flow back up. So we're traversing from the ocean into the middle of the cell, pretty much like we're going from the ocean up instead of going up into the ocean, right? So that's the explanation for this condition. And if those conditions are met, we can just offer that neighboring cell back into the queue, and then the while loop would continue polling, right? So I think that's okay. So we don't actually need to make this a return anything. We just do queue like that, and then so we perform BFS at the bottom here. Here we're just queuing the values. Pacific queue, add new integer R and C, and this one would be Atlantic queue. So here we're just queuing the values first. We traverse every cell in the grid, and we're just traversing it. And then for Atlantic, we're also doing the same thing if it meets these conditions. And from there, we do the BFS on both. And that should modify these two arrays to give us the Boolean to the array of each ocean's reachable cells. And from there, we compare them. So let's try this out. Line 12. Okay, let's see. Semicolon. Line 70. Extra bracket there. Line 76. Extra bracket. 86, semicolon, RC, RC, RC. So we actually don't need to pass these in. Okay. Okay, and there we go. It took, like, it's kind of a hard implementation, but yeah, there's a lot of debugging you could possibly do in this question, but the solution is pretty straightforward. You just do a BFS from the Pacific side and a BFS from the Atlantic side, and then you find the intersection cells. So for this example, every brown or orangish color cell in here is the intersection between the BFS from Pacific and Atlantic. So yeah,